And question 15, we're asked to solve this pair of simultaneous equations, and there's numerous different methods by which you could do this. I'm going to do it by substitution, and the reason I'm picking substitution is because I've got an x here on its own, so it's easy for me to rearrange the first equation to get it in the form x equals. So from the first equation, if I want x on its own, I'm going to move the 2y, so I'm going to get x equals 4 minus 2y. And then in the second equation, it says 2x plus 5y equals 11, so I can substitute for x, because it says x here, and I've got x equals here. So I say 2 lots of 4 minus 2y, because that's what x is, plus 5y equals 11. So if I expand this bracket, I'm going to get 8 minus 4y plus 5y equals 11. So minus 4y plus 5y would just be positive y, and then I've still got the plus 8 and I've still got the 11, which means y is equal to 11 minus 8, which means y is equal to 3. Okay, then how do I find out what x is? Well, if you remember, before I had this formula here, which was x equals 4 minus 2y, so now I know that y is 3, I can substitute 3 in for y and say that x equals 4 minus 2 lots of 3, and 4 take away 2 lots of 3 would be 6, 4 take away 6 would be minus 2. Okay, so I know that x equals to minus 2 and y equals to 3. In an exam, what you could do is substitute these back in here and check that it works for both equations. So for equation 1, if x is minus 2, it's minus 2 plus 2 times 3, and that should equal to 4. So let's check. Minus 2 plus 6 equals 4, fine. And then for the second equation, 2 times x, so 2 lots of minus 2 plus 5 lots of 3, and that should equal to 11. So let's check. Minus 2 times 2 is minus 4, and 5 times 3 is 15, and minus 4 plus 15 is 11. So you can see that you've got your answer correct.